our lesson. We stopped at this point. In the morning, we did say about the Big Bang theory, and we watched the video that explains what is the Big Bang. We did say about the Hubble law, and we did say also about the moving of galaxies and the formation of the universe. But now I let you know about some idea about the cosmic background radiation, about the radiation of some waves like the microwave waves in the vacuum, the space, how this cosmic radiations affect on the universe, and what's about the cosmic background radiation. You know, radiation is something that comes out from the materials when it radiates by the time, by the changing temperature and the pressure around it. It starts to radiate. To radiate means it becomes very, very small particles or materials in the space. Let's see now with this video to take an idea.
I didn't finish writing the question.
Yeah, you're welcome. Go on.
لا I didn't finish writing اللي هي الكوتشن اللي هي apply it.
Yeah, I will send answer. Don't worry about this answer. I will send it when we finish the lesson, inshallah. Recently, we just focused in 30 minutes. We should finish this part of the lesson. Then for the answers, all I will send them, inshallah, for you. Don't worry, right? Thanks.
Assalamu alaikum.
Alaikum salam. You're welcome, ya batal. Let's focus with this video now. We will not study, we will not watch all the video, but about the cosmic radiations and the Big Bang theory only.
Yes. And then based on the theory, what we should be observing today. So the Big Bang starts with all of the mass and space in the universe, an infinitely dense singularity. And a singularity is just something that the math doesn't even apply to it. We don't even know how to understand that. But immediately after the Big Bang, so this occurred 13.7 billion years ago. 13.7 billion.
If this is the age of the universe.
Immediately after this little tiny, infinitely small singularity begins to expand. And so for the first 100,000 years, it's still pretty dense. So let me just show this right now. So then it starts to expand. So maybe it gets to this.
You see, the dot becomes a circle.
Here. And I do not know if the entire universe is infinite or finite, whether it's whether it's a four-dimensional sphere, or whether it goes infinitely in every directions, or whether it's just slightly curved here.
So the dot becomes a sphere. This sphere becomes wider and larger by the time. Look, so this means Big Bang becomes massive explosion in one time.
Here and there, and maybe flat everywhere else. I won't go into all of that. But then it starts to expand a little bit from the singularity, but it's still extremely dense. It's still extremely
dense. Means heavy and has a high density, I mean.
It's so dense that atoms can't even form. So you just have the basic fundamental building blocks of atoms are just all flying around. Electrons and protons, they're just flying around in just this ultra hot, white hot, I could say.
Hot means high temperature with photons or electrons. So recently, up to now, the atoms are not formed yet. The atoms of materials, of the elements, are not formed. There is no atoms, only photons or electrons.
Or maybe even white hot plasma. So this is, I'll call it white hot plasma.
White hot
plasma. And then if we fast forward a little bit more, and now this is a point that we think we understand well, but this number, I actually looked at some old physics books, and this number has changed in really the last 15, 20 years, so maybe it'll change more. But after 380,000 years from the beginning of the Big Bang, 300,000 years after the Big Bang, I'll call it the BB, 380,000 years after the Big Bang, and obviously this is give or take a couple of years, the universe expands enough. The universe is now large enough, and obviously I'm not drawing things to scale. The universe is now large enough.
Becomes large enough so that it increases in its size. Its density becomes low. It becomes cold now. It is not hot.
and sparse enough that it can cool down a little bit. You don't have as much bumping around. It's still a hot place, but now there's kind of, it cools down enough that electrons can be captured by protons, and you could actually have the first hydrogen atoms can begin to form. The first hydrogen atoms begin to form. They actually condense. And we estimate this temperature to be around 3,000 Kelvin. So we've cooled to 3,000 Kelvin, but this is still a temperature that you would not want to hang out in. It's still extremely, extremely hot. Now, why is this moment important, the first atoms forming? So let's think about what's happening here. You have all of this bumping and interactions, and if because of a bump or some energy release or because of the heat temperature, if a photon is released, it'll be immediately absorbed by something else. If some energy gets released, it'll immediately be absorbed by something else, because the universe is so dense, especially with charged particles. Here, all of a sudden, it's not that dense. So over here, things that were being emitted could not travel long distances. They would immediately bump into something else. While you go over here, and the universe is starting to look like the universe we recognize. All of a sudden, if one of these really hot, and it's still nowhere near as hot as this universe over here, but if one of these hot atoms emits a photon, and they would because they are at 3,000 Kelvin, if they emit a photon, all of a sudden there's actually space for that photon to travel. So for the first time in the history of the universe, 380,000 years after the Big Bang, you now have photons, you now have electromagnetic radiation, you now have information that can travel over long, long distances. So given that this happened, it's still roughly 13.7 billion years ago. 380,000 years is not a lot when you talk about 13.7. It still wouldn't even really change the dial, because we're talking in the hundreds of thousands. 0.7 is 700 million years. So this is actually a very small number. So it's still approximately 13.7 billion. It's really 13.7 minus 380,000 years. But given that this was the first time that information could travel, that photons could travel through space without most of them having to bump into something, especially something that's probably charged, the other interesting thing is that these atoms that formed are now neutral. What could we expect to see today? Well, let's think about it. These photons were emitted 13.7 billion years ago, and they were emitted from every point in the universe. So this is every point in the universe, every point in universe. The universe was a pretty uniform place at that time. Very minor irregularities, but you could see because it was this white hot thing just began to condense, it hadn't formed a lot of the structures that we now associate with the universe. It was just kind of a fairly uniform spread of, at that time, reasonably hot.
So this is the first stage of formation of the atoms after photons in the space. If we have atoms, we have elements, then we have materials like rocks, like planets, like stars, like galaxies. So this is the first moment of formation of galaxies and stars. Let's focus about it, please.
Hydrogen atoms. So this is every point in the universe. So let's think about what's going on here. Let me draw another diagram. Let's say that, so we're talking about this point in the universe right over here. The universe is at even 380,000 years after the Big Bang, still much, 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 much smaller than the universe today. But let's say that this is the point in the universe where we happen to be now. At this point in time, there was no Earth, there was no solar system, there was no Milky Way. It was just a bunch of hot hydrogen atoms. Now, if we were at this point in the universe, there must have been
atoms. You see, hot hydrogen atoms means the first atom of a gas ever in the universe. Then you have atoms or gases, then you have galaxies and the stars.
Points in the universe.
Subhanallah. It's a very, very old accident.
There must have been points in the universe at that exact same time, that were emitting this radiation, that were emitting this radiation. And there were actually every point in the universe was emitting this radiation. See, they have radiation now.
Radiation means they check in the vacuum. Someone can ask himself, Mister, how did they know this? Is this for sure or just their expectations?
Yeah, Mister, every time I see something over 1 million years ago. I ask how they know.
I appreciate your question, but I just like you to know that Allah subhanahu wa ta'ala said, ما أشهدتهم خلق السماوات والأرض ولا خلق أنفسهم. But we as Muslims can say the just expectations related to science, because now we are at the end of the creation. If you are in the end of the stairs, at the last stair on the above, you should know how did you start on the first stair on ground. You know, I mean, if you build your house and you finished it well, you start to live inside. So you know about its history. You know about its first steps. How did you do it? So now we just take it in background steps from the newest to the oldest step. So it's just expectations, and they are supported with the scientific laws, like the Hubble law, like the density law, like the physics laws, as you know and you studied before. So don't worry, it's quite accurate and it's quite right expectations because they depend on science.
In the universe where we are now is emitting this radiation. And some of that radiation, so the points that were closer to us, it was emitting that radiation, but it got to us much sooner. It got to us billions of years ago. But there were some points that were far enough that that radiation must be getting to us right now. Or another way to think about it is that radiation has taken 13.7 billion years to reach us. So let me draw. So if I were to draw the visible
SubhanAllah, so the radiation of these photons, of these atoms, takes about millions of years to reach us. So this light that you see on the sun may be taken millions of years to reach the Earth planet, because it's the only star in the vacuum in the space, and there are millions of light years.
I have a question.
Yeah, what is it?
How, Mister, does it take millions of years and the sun, its light is transferred to us in 8 minutes?
Not the sun, but you can say the light of the sun. Only the light of the sun.
Mister.
But how many years for the sun to be formed? The first.
The light,
The sun-
I heard, Mister, that the
Just a
light from
point
the sun.
like this.
Yes, I heard, Mister, that the light from the sun is transferred to Earth in 8 minutes.
Yes, you're right. I agree with you.
Then how does it take millions of years?
Millions of years for the sun to be formed, not for the light of the sun.
Okay.
To collect all of these cosmics, to collect all of these points or these photons to make a star, which is the sun or whatever star is. Maybe another star, not only the sun, because sun is only one star in our solar system. But we have millions of solar systems. We have millions of galaxies in the vacuum, in the space, in the universe. You know? So let's
Yes,
back
Mr.
to our book now. We have an idea about the radiation now, which is the materials of the points in the vacuum to deliver the light for us on the planets. Let's focus now with this one, cosmic background radiation. You see this point? It expands, becomes larger, is spread out everywhere. It makes a sphere, as you see. Let's see now with who can read this text, ya shabab. I think the video was so clear, but we should complete its watching. Inshallah, I will send its link to you. Thank you, Muhammad, if you read this one. Muhammad Amr. I make you focus well. Muhammad Amr is here. Muhammad Amr. You still
Mr.
need
Muhammad Amr's mic doesn't work.
Yeah, but inside the class, his mic is working well. Huh? Anyway, no problem. Thank you, Muhammad Amr, for being not ready. Muhammad Firas.
أنا جاهز لك يا مستر.
ما شاء الله عليك. جزاك الله خير محمد. Read, my dear.
From the another piece?
Cosmic background radiation.
Oh. Cosmic background radiation. Another piece of evidence for the Big Bang was discovered by accident. In 1965, two American physicists, Arno Penzias and
Physicists
physicists
means
Arno
the
and
specialize of studying physics.
Arno Penzias and Robert Wilson
Their
detected
names.
faint. Yes, this is the names. Detected faint radiation on the radio telescope coming from all directions.
Stop. Faint
Science,
radiation means fake radiation or very small radiations. They study it by using the radio telescope coming from all the directions in the space. Okay, scientists.
Scientists later concluded that this cosmic background radiation is the leftover thermal energy from the Big Bang. This energy was
Stop. Is what? Its nature is about what? Leftover thermal energy from the Big Bang. So the Big Bang, when it happened, it has a radiation. Like when you break your house, لا قدر الله, you see the radiation of the dust around everywhere, right?
yes.
So the same happened with the Big Bang. It has a radiation in the vacuum, huh? And it has a sign that Big Bang happened. Good. Continue.
This energy was distributed in every direction as the universe expanded.
So stop here. You see this in this diagram, sorry, in this figure, the yellow one. The Big Bang here, the first point was here that Allah subhanahu wa ta'ala has created. Then it expands everywhere. It has a radiation everywhere, in every direction. You see the red points. These red points are the radiation of the Big Bang. So they spread everywhere in the universe when it expands in any direction. Do you think that the universe has age? Yes, it has age. Continue, Muhammad. This one is a telescope, ya shabab, that they use. This telescope is called what, ya Muhammad? You said now it's a name. Using radio telescope. This one is called radio telescope, ya أولاد, ya shabab. This one is not Hubble. Anyway, let's see now. Let's see now about the age of the universe. Go on, Muhammad. Read the age of the universe.
Okay, Mr. The age of the universe. By measuring how fast the universe is expanding, astronomers can infer how long it has been expanding. The COBE satellite shown measured the cosmic background radiation, which also gave clues to the age of the universe.
So we can find out how much is the age of the universe or not by using this evidence. How fast the universe is expanding, astronomers can infer how long
Mr. The
it
period
has been
finished.
expanding. No, still we have 10 minutes.
Finishes at 12, I think.
12:10, my dear. 12:10, my dear.
Okay.
Don't be upset if we have more 10 minutes, but I think it's good for you to finish this topic. If you have any questions, you can answer them. Then we go to pray, inshallah. The session is finished at 12:10.
Okay, Mr.
So by using the radiations, we can determine, as astronomers, not me or you, we are just students, but I mean astronomers in the spaceships or in the space stations like NASA. They use the radiations to have an idea about how long it has been expanding for the universe. The COOP satellites, like this one in the diagram on the left side of the page, the COOP satellites show and measured the cosmic background radiation. You see these dots, the white dots in the diagram, you see them? The white ones are collected in lines. They form what? They form cosmic background radiation. You see? This one in the vacuum in the universe. So they can measure its expanding so that they can infer how long it has been expanding as a universe. Which also gave clues. Clues here means the crew of the astronomers in the spaceship or in the space station to the age of the universe. So do you think with me the age of the universe is longer than 13.7 billions of years or not? It is younger than 13 billions of years, or it's aged than 13 billions, 0.7 billions of years. How do you see? How old our universe, Shabab? Let's see the first
I
point.
think, Mr.
Let's
it
see the
is
first
older
point of the
than
lesson.
13.
What do you say? You see this
I
number?
think, yes.
This number is the age of the Big Bang when it starts ago. This is one is approximately, not accurately. You cannot say in which time exactly the Big Bang happened, but we as astronomers try to put as much as we can the accurate time of Big Bang theory. So it should be older than 13.7 billions of years. Now I open the camera with you. If you have any question about this lesson, I'm ready. If you still have any concerns, any discussion about the Big Bang theory, about the cosmic background radiation and its benefit to infer the age of the universe or to infer the way of formation of atoms or gases or materials in the space. If you have any questions, Shabab, before we send the answers for you in the groups. Any question? Okay, let's see now the iExcel account that I formed for you. This is called iExcel website. If you search on Google with iExcel sign in, you can create your account, real account for 1 month. Then you will have an account to access many subjects you study, like math, science, social, English, and about more than 200 skill in each subject you can study. Inshallah, in the class, we will have
Mr. I have
time.
a question.
Yeah.
Mr. Why couldn't you just put the homework in the MLG? Why did you open another website?
I put on MLG, but only for 1 week that I studied. I taught you. I didn't teach you before, so I don't have the accessibility or the ability to put on the last previous weeks on MLG. For this one, is not homework, Mr. Shabab. It is just to improve your skills in science map test. It is optional. عشان محمد فراس don't worry, and Firas don't worry, it's optional, it's extra work, it's remedial classes. We do it to improve our skills to be ready more for the map test. I'm coming to support you as much as I can in the map test because your general score is low. I thank online teaching because we have a good chance now to tell you about everything in quiet mode because you don't care in the class a lot of the time. Now you did see the depth of studying science. How should it have quietness mode to understand it well? I think if you watch this video again or this session, just recorded session again, you will know that you should be more quiet inside the class to study well. you think now we should be more quiet, especially in science, because it's not only about English, it's English and science in one subject. So you should focus more and more. If I'm giving you extra job, it is not by obligation, but we will do it with each other in remedial classes in the class. We will open the screen. We will answer all of these skills in science, inshallah. So don't worry, Shabab. I will support you as much as I can. I will support you all the time I have, all the effort I have, inshallah. But for the day, today, just study first and second pages of this lesson, page 154 and 155. Okay, my dears, any question before we leave?
No, no, mister.
Any questions, silent people, silent students, Shabab? You understand it well?
Yes, I understand.
I will send you the link of the video to watch it again, inshallah, the night. Also, I will send you the answers of the check understand the questions in your book at page 154 and 55. Okay, my dears?
Okay.
Okay, mister.
Thank you. Thank you, everyone. Omar Muhammad, the most active students. Assalamu alaikum wa rahmatullahi wa barakatuh.
وعليكم السلام ورحمة الله وبركاته.